Our last lesson that's going to be on this test. This lesson is called Exponential Functions.
What's that?
An exponential function is a function that can be an equation. So it's an equation in the form of y equals ab to the x power. So basically, it's an equation that has y equals a number, which is called a constant, raised to a variable. So it's in the form y equals some number raised to x. So our first step is to make a table. So here's example number 1. Let's make a table.
Is the number your constant?
Mm-hmm.
Why is it? Why?
This is what y equals, and then there's going to be a number here. Okay, so here, like in this example, our equation is y equals 4 to the x power. So let's make a table, just a t-table. Every time we have to make 5 ordered pairs. Okay, we have to make 5 ordered pairs. We are going to use these same numbers every time. I want negative, I want 0, and I want positive. So I'm going to use, this is your x, and this is your y. So for our x coordinates, we're going to use the points negative 2, negative 1, 0, 1, and 2. To find y, we need to plug these numbers into the x position to find y. So y is equal to 4 raised to the x power. Well, let's find out what that is. 4 raised to negative 2 .0625. Did you plug it into your calculator? Okay, well, Steve, if you want to get technical, isn't this just, this is 4 raised to negative 2, right? How do I make an exponent positive? You take it underneath, so this is 4 squared. What is 4 squared?
16.
So what's 1 divided by 16? That same answer. Okay, it's just easier to plug it in. Let's plug in everything else. 4 raised to negative 1 is 0.25. The rest of these you should not have to plug into your calculator. 4 raised to 0. 4 raised to 1. 4 squared. So what you just made 5 ordered pairs. So you don't have to write them out, but if you wanted to, this would be negative 2, comma, 0.0625. This would be negative 1, 0.25, 0, 1, 1, 4, and 2, 16. All right, to the best of your ability, I want us to graph these. It's not going to be perfect. Some of them are going to go off the charts. It is okay. So right here, let's graph. Starting at 0, 0, we need to go left or right, negative 2. So go negative 2, up 0.0625. Well, how do I do that? Yeah, just put like way down here. So just put something way down here. It's not touching the x-axis, but it's very close. All right, next, negative 1 up a quarter. So not half, but halfway between 0 and half. All right, next, 0 up 1 over 1 up 4 And then last is over 2 and up, 16. I don't even have enough graph for that, do I? So just put a dot. And then connect your points. An exponential graph is always going to be curvy. Okay, it's going to be curved. Remember our graph from the bell ringer today, where Reese graphed it? What did it look like? A straight line. What kind of line is that called? Linear. Good. Exponential is one that's always, it's always curved, like this. Okay, so if this was Apple, if this was a graph about Apple products, Apple Watch, iPhone, all of it together, would you say their company is growing or dying? Growing. So there's two kinds of exponential graphs. There's growing and decaying. This is obviously an example of growing. So if on your test, if you're asked, is this growing or decaying, you would say growing. Now there's one more thing we need to do. We need to talk about the domain and the range of this graph. Domain is always the what? Range is always the. So domain goes side to side. Side to side. It's like a laser going side to side. Okay. How far will I go? Isn't it an arrow? So couldn't I go forever and ever and ever? I just picked 5 points. It doesn't end there. It keeps going. So our domain is all real numbers.
Does it matter what 5 numbers?
No, but I would use the same ones. So our domain is just side to side because yes, it goes right here, but it keeps going. We just didn't pick those numbers. Okay, over here, it keeps going. We didn't pick those numbers. Now your range is up and down. Do I ever go past the x-axis? No. So your range, which is y, is always greater than what number?
0.
0. Good job. 0. Now, your domain is going to be all real numbers a lot. So do you want to know a symbol?
What?
A symbol for writing all real numbers? Okay, this is the symbol for all real numbers. This is just a box. That's not the symbol. The symbol's going inside of it. Draw 2 parallel lines. And then make it an R. So start with the back one and make an R. That's the symbol for all real numbers.
What's that supposed to mean?
It means all real numbers.
How's it hard to read?
All real numbers. So let's just, I'm not sure, this isn't for real, but for us, this extra parallel line stands for L, all, and then your R stands for?
Real numbers. What numbers are they?
All of them. All real numbers. All right, let's try the next one. First thing we're going to do is draw our graph. You don't have to use my numbers, but I'm using -2, -1, 0, 1, and 2. Here's your x. Here's your y. This time, we're plugging into 1 divided by 4. So if you're using your calculator, I would open your parentheses, 1 divided by 4, close your parentheses, and raise it, use your caret, -2. 1/4 raised to the -2 is 16.
What was that?
-1 raised to, 1/4 raised to the -1st power is 4. 1/4 raised to the 0 power. 1/4 raised to the 1st power. 1/4. But which way? It's easier to graph a decimal, right? So what's 1/4 as a decimal? 0.25. And then 1/4 raised to the second power is 1/16. But see, if it's easier to graph a decimal, so I would do 1 divided by 16 and see your decimal is 0.0625. Okay, just easier. All right, graph. Now, so you can write these out if you prefer. If you can graph straight from this and know that these 2 points go together, that's fine. So -2 to 16 off the chart. -1 up 4. 0, 1. Over 1 up 1/4. Over 2 up 1/4 of 1/4. Half of 1/4.
15.
All right, connect your points.
15. Oh,
Connect your points. What restaurant do you really not like? Okay, Burger King. Burger King. All right. Well, for those of us who don't like Burger King, are their stats growing or decaying? Decaying. They were doing real good. And then they stopped. So this would be decaying. Now, I need you to write your domain and your range. Your domain is always your x, side to side. We only picked 5 points. If I picked other points, would it keep going? So it's what? Okay, so I'm going to use my symbol. If you don't like using that symbol, just use all real numbers. Okay, our range is up and down. It goes up forever and ever and ever. But what does it never go past? 0. So y, so your y stays above 0. On your study guide and your test, yes. On the back of this page, no.
Wait, so domain is always going to be all numbers?
Yes. And your range is always going to be 0, except for on the back of this paper. So on your test and on your study guide, these are the exact same domain and range.
So that's the answer.
Every time.
Every time.
Except for
The back of this
on the
page.
back of this page.
So that's a test answer right there.
Yes.
I like this.
All right, try the third one. Y'all need all the easy points you can get. Steve, don't you worry.
I don't have to worry.
Oh, you don't? You're good?
Say that. Okay, just let her say it out loud.
62.